Okay, we're gonna move on to an E1 reaction. All right, but let's review all reactions we have learned so far. First of all, SN2, you're probably familiar by now. We have a nucleophile and lystically hindered alkyl halide. So nucleophilic attack or backside attack, you get the product right away. All right, and there's only one step. So there's a rate determining step. The rate must depends on the concentration of nucleophile and alkyl halide. You decrease or increase any of these affect the rate. All right, because both of them are involved in the rate determining step. Now in E2, so the alkyl halide is bulky, sterically hindered, block an SN2 reaction. So hydroxide cannot do an SN2, and it said, oh well, can do SN2. Well, never mind, let's do E2 instead. All right. So in this case, you're gonna get an elimination product, and the rate law is still the same. It's a bimolecular reaction. There's only one step. That's a rate determining step, of course, right? And the rate, and there are two species involved in the rate determining step. If you increase, decrease, or change concentration, any of these two affect the rate. Okay, so SN2 and E2. Now move on to SN1 and E1 and compare and contrast right here. The first step of these two mechanisms are exactly the same: solvolysis or carbocation formation by the solvent. All right, you get a carbocation, and then this depends now. Oh, by the way, so this is the rate determining step. All right, so only one species is involved in the rate determining step. That's the reason why SN1 and E1 is a unique molecular reaction. Okay, just one species. And then if the reagent acts as a nucleophile, you will go SN1. All right, proton transfer, you should get the product there. And unique molecular reaction. The concentration of the reagent, which is water right now, nucleophile, is not on here. You can do whatever with water. Increase concentration, decrease conformation does not affect the rate. Only these species right here, the alkyl halides, affect the rate. Same thing with similar to SN1, E1. Normally it doesn't really occur, but if you heat it up under an elevated temperature, water will do an E1, do elimination, and you get that product. All right. This is also a unique molecular reaction. Change of concentration of water does not affect the rate. Only the concentration of the alkyl halide, because there's only one species in the rate determining step. Water doesn't do anything. Okay. All right. Now, a little bit about SN1 and E1. Okay, SN1 and E1 are always in competition. If you do an SN1, you're gonna get some E1. If you want to make a lot of E1, you always get some SN1 product. All right, they are always in competition, but most of the time SN1 is favored. All right. Take a look right here. So if they have this compound, alkyl halide add in ethanol. So solvolysis. Let me talk about this guy real quick. So there's a solvent and lysis. There's a two word in there. Solvent means solvent, of course, and lysis means cut bond. Right? So cut bond by a solvent. You probably have heard hydrolysis. Hydrolysis, cutting chemical bond with water. Solvolysis does that, the same thing, but by the solvent. Okay. So from this one, what happens? Put this compound in ethanol. Ethanol will interact with bromine, pull bromine out basically from a carbocation. That's what we call solvolysis. So solvent facilitate carbocation formation. And from this carbocation, you can do either SN1 or E1. But most of the time, this reaction favors SN1 mechanism. Okay, so you're going to get SN1 as a major product. However, if you heat it up, that's when E1 elimination is favored. Okay, but SN1 and E1 are always in competition. That's why there is no too little use of an in E1 mechanism, because you're gonna get the multiple products in there. Right? There'll be multiple times that we use E1, but not a lot. Right? So sometimes it's rearranged. All right. Let's be familiar with an E1 real quick, just mechanism. All right. So first step, just like an SN1, carbocation formation. There's a rate determining step. All right. And then this one's going to be similar to an E2. Actually, exactly the same like E2. Find beta hydrogen from the carbocation. We have alpha, we have beta right there. Deprotonation, you get a double bond there. There are multiple beta position in this structure. These two are the same. There's another one right there at the top. You can do another beta hydrogen there. Here we go. You get two products there. And you can guess which one is a major one. The more substitute alkene, the more stable one. So its transition state should be more stable than the other one. So reaction go faster. All right, make more of this. All right, okay, let's move on to a little bit more, some more about the rate of E1 reaction in terms of alkyl halides. All right.